After struggling a lot with tuning my loaded coil dipole antennas, I decided to buy a NanoVNA, which is an affordable handheld antenna analyzer widely used by radio amateurs globally. The version which I have ordered is NanoVNA H V3.6 and I hope it will be delivered next week or so. I found the NanoVNA.com as a very useful resource and decided to go through it at leisure and post relevant information here. Please join me in this learning process and you are welcome to ask questions and give me your valuable suggestions. NanoVNA H is Huygens version with a 5V DC-DC boost converter which ensures stable operation driven solely by a 3.7V lithium-ion battery. Latest versions are NanoVNA H Rev 3.6, which I think I have ordered for 5,800 INR, $67, and a costlier NanoVNA H4 Rev 4.3, while the original NanoVNA had a 40 dB dynamic range at 900 MHz. The current versions can achieve 40 dB dynamic range up to 1.5 GHz and should be quite enough for my activities, which range only up to the UHF amateur radio band, typically the 437.800 MHz downlink frequency of International Space Station. For starting work, it has been mentioned that you need NanoVNA, SMA load 50 ohms, SMA short, SMA open, SMA female to female through connector, and SMA male to male cable into 2. Whiskey Alpha 5 Oscar Kilo Oscar has suggested that as SMA connectors on the device can wear off, an SMA male to SMA female adapter has to be used, which are easier to replace. It is similar to the PL259 to SO239 patch cable which I use with my radios to prevent damage to the SO239 connector on the radio by repeated screwing and unscrewing of the antennas. USB Type-C cable which comes with the NanoVNA can be used for charging the device by plugging into a 5V USB power source. A USB-C connector on the NanoVNA is a bipolar connector. Battery status indicator LED blinks while charging and stops blinking when the charging is complete. If you are planning to use SMA male to SO239 patch cables, then corresponding PL259 load 50 ohms, PL259 short and PL259 open will be needed for calibration. PL259 load 50 ohms can be made using 200 ohm resistors in parallel connected to the PL259. I need an SMA male to SO239 patch cable as my antennas terminate in PL259 connectors. Note that SMA male connector has pin in the center and thread on the inner aspect of the connector. When SMA male to SO239 patch cable is being used, calibration should be done with the cable and corresponding PL259s as mentioned above connected. Calibration with the SMA connectors as mentioned earlier is not enough. Fundamental oscillation frequency of NanoVNA is from 50 kHz to 300 MHz. Harmonics are used for higher frequencies. Third harmonic is used for frequencies from 300 MHz to 900 MHz, while fifth harmonic is used for 900 MHz to 1.5 GHz. Calibration of NanoVNA has to be done whenever frequency range to be measured is changed. It is for calibration that we need the SMA load 50 ohms, SMA short and SMA open connectors. During calibration, these connectors are connected to port 1 marked CH0 one at a time. Port 2 marked CH1 can be left unconnected. Calibration status is displayed on a side of the screen. Calibration procedure will be discussed in detail later. As you can see from the image, there are two SMA ports for the NanoVNA on one side, which are meant for S11 and S21 measurement. S11 is used for measurement of SWR, in which RF energy from the oscillator is transmitted and reflected energy compared to the forward energy. S21 is used for measuring insertion loss of a length of cable, in which case the transmitted output is compared to the level received by the receiver. My friend N8LIVU2 LID has warned me that input of the device can easily be damaged with excessive input, and one has to be careful about transmissions and extremely strong nearby stations. On the back cover of the NanoVNA, S11 is marked as TX and S21 as RX.